Hello friends, today we are going to discuss performance requalification of the compressed air and distribution system. So what are the parameters to be performed in the performance requalification or performance qualification of compressed air system that specifically we discuss in this training. Previously we have discussed from the URS to the performance qualification. Now today we are going only for the focus on the performance requalification of the compressed air system. So there is one basic guidelines for the performance qualification or requalification of the compressed air system, that is the ISO 8573 part 1 to 10 that published in 2010. And one more guidelines that you can refer for the performance qualification and commissioning of the compressed air system, that is the ISP guideline for the process gases. Okay, so basically these are the some tests that we have to include in our test plan and the performance qualification or requalification, that is the description of the compressed air, dew point, water contents, oil vapors, non-viable particle counts, viable particle counts, carbon dioxide, carbon monoxide, sulfur dioxide, and nitrous oxide. That is the some basic test that we have to include in the test parameters of our qualification plan. Okay, apart from this we can also test for the hydrocarbon, lower hydrocarbon and higher hydrocarbon oxygen contents in the compressed air. Okay, so these are the some basic tests that we have to perform. So for a dew point that we have to measure, that is according to the class of the compressed air. First we have to assess which classification our compressed air system is, in which classification we fall. Then accordingly we have to plan for the test of the pressure dew point. The apparatus used for this test pressure dew point, that is the digital pressure dew point or online pressure dew point. So class 0 to class 6 we can measure the dew point in the degree Celsius or Fahrenheit. So minus 40, minus 70, minus 20, plus 3, plus 7 and plus 10, that is the dew point range, pressure dew point range. This is not atmospheric dew point, this is the pressure dew point that should be measure more than 1 kg per centimeter square pressure. Okay, so accordingly we have suppose we have the compressed air of the class 2, then that should be pressure dew point minus 40 degrees Celsius, not less than this. That is 39 degrees Celsius, minus 39 degrees Celsius is not acceptable. Minus 40, minus 40.1 or minus 50, that will be acceptable. Okay, that is the apparatus, that is the graphical representation of the apparatus that we can use for the determination or online verification of the dew point meter. Okay, then water vapors. Water vapor, basically these are the water contents or water vapor that will be present in the air stream or compressed air after the drying. Okay, we can use the desiccant type or silica gel type dryer, we can use the heatless dryer, or we can use the refrigerant dryer. So which type of dryer we are using, based on that these water contents or water vapor and dew point is highly dependent on the class of the dryer. So if we are using the refrigerant air dryer, we can use the 6 AG. There are two tubes basically we are using, 6 AG and 6A. These are only difference in the range of the this water contents. So 6 AG having the higher range, 150 to 3000 meter mg per meter cube, because this if the water content is more than the 150 mg per meter cube, this tube can be used. Okay, specifically for the refrigerant dryer, which can give the dew point plus 3. Okay, not more than plus 3. So in that case we can use this type of water gastric tube. This is basically gastric tube. Sampling rate as 300 ml per minute for the sample for the 1 minute. So the color change in this, you can see the green to purple. So you can directly read the reading on the scale. This is the scale, and you can read the change in the scale. So up to which the color is changed in 1 minute, that will be your moisture contents. Okay, second tube we are using, that is the 6A. This is the lower range, like 10 to 80 mg per meter cube. This is the for the small one. Okay, 100 ml per minute is the sampling rate for the 5 minutes. Okay, we have to sample for the 5 minutes, and this is the 100 ml, that is the sampling rate. Okay, and the color change in this, you can see the yellow to green. Okay, this is the different, this is the reaction that will be happen, and due to this reaction the color will be changed. Okay, so up to which the color is changed, that will be your reading. This is used in those type of generation system or distribution system where we are using desiccant type of air dryer, silica gel, activated charcoal. Okay, which can reduce the dew point minus 40 or minus 60 degrees Celsius. Okay, then we can use this type of tube. There is a less chances of water content. So for less traces of water vapor, we can use this type of tube. Okay, now the next test for the performance qualification or requalification, that is the oil vapors or a mixture of hydrocarbon composed of 6 or more than carbon atom. This is called the oil vapors. So the concentration is measured in the liquid aerosol vapors mg per meter cube. So depending upon the class, like similar to the water vapor, it is also depend upon the class. So 0, 1, 2, 3, 4, 5, these are the classes of the compressed air. So for if we have the compressed air generation and distribution system falling in the class 2, then our range is less than zero point 0.1 milligram per meter cube. If we are using the class 1 air compressor and air compressed air generation system, then it should be less than 0.01 gram. So for this determination, we can use the on-site detector tube, that is the gastric tube. We can directly use with the gastric pump or the setup for the online setup with the rotameter. Okay, so for this we are using 109 AD gastric tube. This is the standard tube that we are used for the determination of the detection of the oil vapors in the compressed air. Okay, sampling rate is 1000 ml per minute for the 20 minutes, and the color change will be the pale red to the pale blue. Okay, this is the color change in, if we detected the oil in the uh, compressed air generation and distribution system. Okay, so this is the new tube, and when there is any detection of the uh, oil, that will be change the color. Okay, so we can directly read the uh, color change on the scale, and accordingly we can write the value. Okay, if we have the range of the compressed air measuring range is 0.1 to 0.2 milligram per meter cube, then we have to sample 40 minutes. If we have the range 0.2 to 5 milligram per meter cube, then we have to sample for 20 minutes. This is the pale vermilion to pale blue color will be there. Okay, next test is the non-viable particle count. For this we can use the particle counter, specifically non-viable particle counter, laser based particle counter, which are used for the sampling of the compressed air. So we required some diffuser to reduce the pressure of the compressed air. So with the help of diffuser we can sample the 1 meter cube air in the air sampler, and after that we have to the particle counter will give the result of the particles. So zero point 0.1 to 0.5, zero point 5 to 1, and 1 to 5 microns depending upon the class. If suppose we have the class 2 air, then it's the 400,000, then 6,000, and then 100. Okay, less than 100, less than 6,000, and less than 400,000. So this will be the value. Okay, so our value should be below this limits, then we can say yes, our compressed air system made the class 2 classification. Okay, viable particle count. For viable particle count, we are using the air sampler, upon which there is a one more attachment that will be attached on the head of this uh, air sampler, and then directly air coming from this side through this header with the help of rotameter, and then the diffuser that regulate the air compression pressure, and then it will go through this plates. This plate will settle down the particle. Here is the media, and this media, all the particles settle on the media, and then air is passed through this sampler. Okay, 1 meter cube sample we have to collect it from the compressed air points, and then it will directly incubate to the incubation for the 5 days. Then carbon dioxide. For carbon dioxide, we can use the two-way gastric tube, which have the ranging 250 to 3000, because the acceptance criteria for the compressed air system for the contamination of carbon dioxide, it should not be more than the 500 ppm. So 250 to 3000 is suitable for the determination of carbon dioxide contents. We can see the color change in the this from yellowish orange to the yellow. Okay, so we can directly read the readings over the tube and then note down the readings. This carbon monoxide is detected with the help of detector tube 1LC gastric detection tube, and then the reaction color change white to pale pink. Okay, you can see the image here is the totally pure white and it is like slightly pale pink. So you can read directly the reading. So 1 to 30 ppm is the range. So it should not more than the 5 ppm. Okay. Sulfur dioxide at its range from the zero point 0.1 to 0.25 and 0.25 to 10 and 10 to 22 microns. So sulfur dioxide, we are using the gastric tube 5LC and the range is 0.02 ppm to uh, 5 ppm. Okay, and or to 10 ppm. So we can use the suitable, depending upon our protocol range, we can use the detector tube of suitable range. So it should not be more than 1 ppm, and the sampling time is 8 minutes. The color change is bluish to purple, bluish purple to the white. So you can see this is the bluish color, and then it will change to the white color, and you can read the direct reading upon up to which the color is changed. Nitrogen oxide NO2, we are using 11L gastric tube, and the range is 0.03 to 0.06 ppm, 0.06 to 0.2 ppm, and zero point 0.2 ppm to 5 ppm, or 5 to 14 ppms. These are coming with the four different range, and for this nitrogen oxide, it should not be more than zero point 0.1 ppm, and the color change is white to yellowish orange. So after performance qualification or requalification, we have to mention the capacity range and recommended operating parameters of the compressed air system, and then equipment handover. After the qualification of the equipments, if it is suitable for the use for the routine or commercial use, we can hand over the system to the end user. So this is all about the performance qualification and requalification of compressed. Thank you for watching our next training video on the cleaning validation. Thank you very much for the subscription.